I had this package called DuckDB in mind to talk about. I was looking through some of the Posit conference talks and saw it was mentioned a couple times. Looked through and saw people weren't really introducing what it was or using specific use cases, sort of assuming you already kind of knew what it was. And I was like interested. I just checked it out yesterday, um, trying to learn a bit about it and thought it was interesting in terms of sort of maybe performance improvements that you can get for certain big data sets. And so I'm going to approach this with the angle of actually, let me just start sharing and we can just jump in. So DuckDB, I guess, is a general thing that's not just an R. It's new to me, but here's the documentation for the R client. And so I guess basically the idea is that it allows you to interact in the context of it allows you to interact with what appears to be like a sort of like a database, like an SQL type database. And today I'll be sort of talking about I'm approaching it from the angle of seeing if you can sort of d take dplyr like code that maybe runs slowly because you're working with big data sets and sort of use this DuckDB tool to sort of do the same sort of operations, but faster and maybe with less memory. So they introduce basically, it's sort of like SQL-Lite, if anyone's familiar with that, sort of like a database that's almost like a virtual database. So you start by just loading the package and you basically connect to like this database. Um, and basically when you do the default arguments, it means that you're going to be storing tables and stuff in memory. So today, that's what I'm going to be talking about. There's other options that are maybe a little bit more complex, um, but I'll just be talking about the in-memory ones. So basically, once you have a database, you can query it with SQL. I know we don't use much SQL, but today I'll be talking about how to write R code and sort of translate into SQL somewhat automatically. But the idea is that you can sort of query this database, query some tables, and you get results back. So if you have like a table called items, you can just select everything from items and then returns it as a data frame. So some useful functions that they highlight here, DB execute when you don't really want something necessarily returned. If you're just trying to add some rows to your table like this, you can just do it like insert into, and then you don't expect anything back. If you do expect something back, I guess I already sort of mentioned this DB get query. So you just write a SQL query and you get stuff back. So right now, I know this probably doesn't sound super like connected to what we do, but I will show an example of how I used it and got some performance benefits writing some R code. And they mentioned a bit about dbplyr. I'm not going to really cover that too much. And then this is sort of the base documentation, but I want to show how to use this in R, like I said. So, by the way, I have some very brief notes just about the functions and stuff that I'll be using for today. I did attach it to the RStats sheet very recently. So I connect to this documentation site, and then I mentioned some of these commands that we'll be using. So with that, I'm going to sort of motivate this, like why am I talking about databases and SQL and stuff? So I'm going to go to a function actually sort of a real world script, something I was writing for some Visium HD work. And so I'm just going to go through like what the script is doing. So Visium HD gives you huge data sets where it's spatial data and in this case, I'm using this fixture tool, which gives you clustering results. So you have cluster calls for a number of bins, and there's millions of bins, tens of millions of bins at the 2 micron scale. And actually, the CSVs that contain the cluster are in long format where maybe I'll go through and actually show. Let me do that. So I think I loaded this, but let me just check. So let me just check that I loaded this. I think I did. So we have a bunch of CSVs. I'm just going to um, show you the first one. So let me just get the path for it. Actually, it's a TSV, but same sort of thing. So over here, I'm just going to maybe should I make this a little bit bigger? So I'm just going to show the head of this. Oh, it copied it literally instead of, that's weird.
The font size.
It said increase, yeah.
Okay.
Yep. So I'm not sure what happened here, but let me try this again. Let me just clear this. This is really messy. Um, um, so I guess this is not super clear, but I'll try to make it, it's a little messy here. But basically, the columns that really matter here are that you have, these are clustering results. You have genes. So this is in long format where you have genes, you have many samples, um, you have a barcode for the bin for each sample, and then you have the cluster call. So there can be multiple genes per sample ID and barcode combination, if that makes sense. So if every bin has multiple genes generally measured. So this can be tens of millions. I should check, but I think it's like maybe 100 million rows or something, very large. And I've done these clustering, done this clustering for a number of values of k. So about 40 different clustering results. So 40 different files that are each like tens of millions of rows. And I wanted to clean this up so that we have sort of like a single CSV with all the clustering results, not in this long format. We don't care about the genes in this case. We just care about the clustering results. So there's a lot of extraneous information here. So this script tries to combine clustering results from all resolutions, um, and put it in a single CSV file. So that it's very normally. So if we go through the script, basically, what I'm doing is I have a spatial experiment object, and I'm just getting the sample ID and barcode at first, so I can. Why did it do that? So I can join it with the clustering results. So why is this here? This is not supposed to be here. In the original, I don't know why it's suggesting some stuff from, wait, okay. Sorry, I don't know what was going on with the AI here, but basically we have the spatial experiment object and we have the barcode and sample ID for all of the bins in the data. Again, tens of millions of bins. And originally I wrote some dplyr code mostly. I did use a little bit of data table just for like reading in quickly, but what I'm doing here is I'm simply looping through all the values of k. So like let's say we have the first one is we're looking for just three clusters. Um, and so we're doing a bunch of dplyr stuff, adding the sample ID, I'm changing stuff to a factor, filtering null values for the cluster, which are possible. And then I'm trying to join that sort of iteratively to the call data of the spatial experiment object so that we have every single clustering result in the call data. And so this took like 6 hours to run, with this dplyr code. And it was already slightly optimized in a way where we have multiple values for the multiple rows for each cluster and sample ID combination. And so when I do a left join, I use this like multiple equals any option, um, rather than trying to get a single row per cluster and sample ID barcode combination, if that makes sense. But anyway, this is sort of a use case I was thinking of trying to write this code with DuckDB. And so I guess I'll just briefly motivate. I do have some results. So I think let me see if I have um, I did sort of like a tiny benchmark. This is my first try using this tool, and I accidentally did not use multiple cores. I should mention that DuckDB does like automatically parallelize things across the available cores, which I haven't tested thoroughly. I accidentally used one core when I ran this instead of maybe four or something. So I'm using Slurm jobs here to get sort of like the runs. So I already before I actually show the code, I did already run this just to sort of motivate things. And the first time I ran it, it was modestly better in memory. So using like 75 gigs instead of 90, not much better, right? So not super motivating yet, but it did run in half the time. So the wall clock time, I'm not going to show it here, but it was a little bit more than double to run the original code. Right. So the DuckDB was like half the time. Um, so I'm already getting some performance improvements, maybe not amazing the first time through with one core, but I'm going to test it later with multiple cores, and I expect that the performance to be better based on how it works. So what does this look like in terms of what am I exactly suggesting or like implying that we do with DuckDB here? So I'm gonna rewrite this, show how to sort of rewrite this code to work with DuckDB. So first thing I'm gonna do is obviously load DuckDB. So why is this doing this? Okay. So based on the logic I'm doing here, again, we're sort of iteratively joining these tables. So I'm gonna try to rewrite this code. I'm gonna first start with like a single value of k. Um, so I'm gonna take this. I'm just gonna take this outside of the loop for now, just to show like an example. So k equals 3 is the first value that we use in this data. So I'm gonna do some stuff here, and really to achieve the same logic that I do here with the multiple equals any, I'm going to, there's multiple genes per clustering result. So what I'm gonna do is I'm gonna do something that's actually very not performant, but I'm gonna do this. And what this is doing is it's saying like, I don't care. I just want one row per sample ID and barcode combination. And I don't care if there's multiple genes. I just take the first one, however it's ordered. So this is sort of really the logic that we're doing for each value of k. So now I'm going to use, so I'm going to start with this code, and I want to directly use, so DuckDB supports a couple of different options, but based on my experience with like dtplyr, which was sort of trying to translate dplyr code into data table, I feel like DuckDB has something similar where it tries to translate your dplyr code into like SQL, and I don't quite trust it, to be honest, based on what happened with dtplyr in my experience, which is basically something was silently mistranslated. So what I'm going to recommend is writing the SQL directly, but you can use AI to help with that. So I'm going to ask, say, pretend this is a database instead of like I'm going to say this highlighted code. Code uses a database instead of a table. Um, Translate dplyr logic into an SQL query and place it below the highlighted code, just so we don't delete anything. Why is it? Okay, let's see if it actually, don't really like that. So it's sort of what it's doing here is it's doing a very literal translation where it's saying like it's grouping by the sample ID and barcode and it's taking the first row. And really what I meant by this logic, or the intent was to get the unique values of sample ID and barcode and not care about the multiple genes. So I'm going to say, um, retry this, but how should I word this? Well, okay, I know SQL, so it helps to just sort of hint at it what it should be doing to capture the intent behind group my plus slice head, which was to get unique values of sample ID plus barcode plus, yeah, I guess that's so sometimes you have to give it a little more hints because I didn't like it was too little. It did it correctly, but it was a literal translation, which yeah, there we go. That's better. I don't know why I commented it, but that's fine. So let's just make this as a put this into a string. Yeah, like that. Yeah. So let me just review this for a second. From fixture table where factor K1 is not null. That's pretty much what I want it to do. Um, so okay, let's clean this up a bit. So I'm going to use a function here. So within here, instead of, let me just do this and I'll explain it. But so instead of from fixture table, we're actually reading from a CSV. So there's this function. I guess those are not good quotes. Where you can use this read CSV auto function. So within the SQL query, and it will read a CSV easily. So it doesn't actually read it until you need the results. So it's a little bit more performant than it's not actually reading into memory completely. So I'm just going to do this into like, I'm going to use a sprintf. So I'm going to make this %s for now. Um, and then let's just call this column cluster. So we have the sample ID, the barcode, and cluster. And okay, so next step, I guess we can so we're gonna have to do this for multiple clusters. So in order to, I don't want to have to copy this. Really, all I want is the sample barcode and then every result clustering result. I don't want the sample barcode cluster. I don't want like 40 data frames that are like this. I want just the sample ID and barcode column once. So what I'm going to do is, um, so sort of assuming you don't know SQL is why I'm doing this with AI a bit, but it helps to know it obviously and to be able to verify that you're doing this correctly. But um, order the highlighted query by sample ID and barcode, then just select factor K1. Okay. So let's see if this is right. Select factor K1 from select distinct. Not sure why it did a subquery here, but okay. Um, mm, Last time I tested this, it did this much better. I don't know why it's kind of messing up here. Um, I'm just
Maybe you actually completed the solution before.
Yeah, I tested this out just to make sure it was actually like a
No, no,
viable.
what I mean is like maybe you actually upgraded the code and AI had access to the actual solution.
Um, I'm not sure. Select. Actually, maybe it does require a subquery. Let me just redo this. And this was working a lot more cleanly last time when I was. I'm trying to. I thought undo was Command Y, but I mean like redo. Let's see if it can. Let's see if it can rewrite this because I just kind of messed it up. Yeah. Select factor order by sample ID bar. Okay. Actually, this is fine. So this is good SQL. It's doing the same logic that we have here. Um, and so let's do this. Let's rewrite this loop with the SQL. So we're gonna loop through. Do we want to join this with the call data immediately? Mm, let's
I think you get it for now and then later decide whether you can join it.
Yeah, I guess it's sort of, I think we do need to join because it doesn't line up. We don't necessarily have the same sample ID and barcodes in these cluster results. So I'm gonna go ahead and do a couple things. So let me refer back to this. So we want to join with the call data. So we want to have to make this accessible to um, the database. So the table name, let's just call it call data. And then the variable we have, why is it doing this? These quotes are bad again.
Yeah.
So we already should have the call data in memory. I already loaded this previously. This should take note. All this is doing is saying like make this a table. It's not doing any copying or anything, so it should be. Did I not? I didn't start the connection like I said I should. So this should be instantaneous. It's not really doing anything. I don't know why it's suggesting that. It's bad. So let's go back down here and add this as a table. And since we're sorting by sample ID and barcode to make sure the order is correct, I'm just going to do something here. So let's do a version where it's sorted the same way. I don't know what this is, but let's write the query here. So let's just sort this call data real quick so we can line it up. Um, it's crazy. Okay. Select sample ID barcode. Yeah, exactly. So it already knew what I was about to do. Um, so this should return a data frame. So this is actually, let me just show you how the size of this object. Um, so the call data is 37 million rows. So we're going to be doing this sorting two different columns with 37 million rows. So let's do this as a SQL query. So it should be relatively fast. I think it normally tells you the progress. Let's see if it shows. There's a little progress bar usually. Um, okay, cool. So just to view this a little easier, I'm going to make it a table and then we can take a look at it. 37 million rows still, it's just sorted. Um, so cool, that was pretty fast. And all right, so we want to join the call data. Make sure to join with sorted. How does this actually, I might have done this. This is my first time working with this. I'm still, there's some hiccups maybe, but I think I might have to register this as, um, now that this is just a data frame, I think I have to register this, make it a, which should be fast. But anyways, I need to highlight this again. Make sure to join with sorted call data before selecting factor K1. So I think the good thing about SQL is it's sort of like it's pretty readable even if you don't know how to write it. Let me just keep this. So select this from sorted call data, left join on. Okay, that's not really what I. So it's joining. It's doing such a bad job compared to what I was doing yesterday. So maybe this is not super consistently reliable. I think you can just do it order by after the like. Yeah. And then I really only care about the factor. So I think that's the query. Okay, well, that's sort of the process, I guess, you can maybe use. It helps in SQL, but like usually this is, at least last time I tried this, it was a little bit smoother than what it has been today. Um, and so now we would sort of, where did I put this? DB get query. So this is going to return this query is going to return a single column. It's a data frame with a single column, just the factor results for this value of k. Um, So I want to maybe basically just add that to a column to sorted call data. And I'm trying to make sure this logic is right. Actually, this should be good. It should take a while. Oh, do I have to do that every time? That's kind of, maybe this is not the cleanest. So I had a cleaner solution yesterday. Okay. Anyways, this is what this might look like. Um, so now this should be a lot faster than, the implementation in dplyr. I guess in my test it was twice as fast. Maybe with more cores it will be even faster, or in other use cases maybe. This is the first one I had. So let's try this. So K, I think K is 3, but hopefully I wrote this correctly. So it's substituting in the path for the value of K, which is 3, and it's putting that path in here so that it reads the CSV there. So this should be right. Sorted call data, I wanted to add this as a column. So like that, since it's a data frame with a single column, which is just the clustering result. So let's iteratively add that to the sorted call data as we keep moving on. So, all right, hopefully this is correct SQL. So yeah, here's the progress meter. It should take a while. Um, and while I'm done with that, I can sort of clean up the script so that it actually runs for, let's not use this dplyr code anymore. Um, and I think this should be basically now we're appending to the sorted call data. So this would be look like this. And then oops. I think everything else is the same. Um, but yeah, I don't know. I think as we work with like larger data sets and stuff, like Visium HD, when we have these massive files and we have multiple versions of these files, this sort of thing will be more helpful. Um, There's probably a cleaner way to implement this than I thought today. I just wanted to connect this to R and not require too much knowledge of SQL. Although I feel like with AI messing up a little bit, you sort of do need to know the SQL. So maybe not super translatable to what we do, but I think this package has definitely potential. I think the multi-core thing is especially exciting because I think right now this script is um requires like 64 gigs of memory, and I'm just using one core, and I feel like often our jobs are very memory hungry compared to how many cores they use. So I think being able to parallelize it across cores would be super useful in the future. So I think there's more to explore with this package. But so it is doing something that's pretty, yeah, it's already done. I mean, it took like obviously like 2 minutes, but this was like I think hundreds of millions of rows, and it's trying to find the unique values in them and then sort it and then join. So it's doing a bunch of stuff. And so sort of call, let's take a look at the result, by the way. Let's make this a tibble because it's a bit data frame. So we have the sample ID, the barcode, and then why is it called this? Interesting. Whoops, I meant to put what I meant to do is this as cluster and then do, because there's a data frame and I meant to return the vector. Um, But anyways, lots of NAs, which for actually, you know what? It looks like it didn't detect the NAs automatically from the file because I did do a where factor is not null and it did not properly detect because I see some string NAs versus some actual NAs here. The actual NAs being from the left join. In any case, so there's a little bit of stuff to clean up here. But yeah, I ran this. It saved several hours of work. Although obviously there's some upfront that it takes. What I'm proposing here is you write the dplyr code first and then do this work to translate to SQL, which obviously is can be non-trivial. So you have to consider, I guess, the value of. I think in this case, for my application, it's probably worth it, worth the performance increase, but maybe others, it's easier to just write the dplyr and accept the small difference in performance if it's smaller. But I think this will be a useful tool in the to take a look at in the future. So yeah, I guess I'll show a couple more things. And then other than that, that's mostly what I had for today. I guess one thing I'll show is so let's see, db get query con select from, I'm sorry, I'm trying to find this code up here. Read CSV auto. Um, Yeah, so what I was going to show is that you can that this is indeed lazy. It's not reading the full CSV, and let's see if it automatically gets this. No, it's not getting it. So I'll just put the actual path in here. Let me clean this off. Oh, there's no sprintf here. Okay. Um, uh, all right, so see how quickly that ran, if you notice, even it was like a second. So it's not reading the full CSV. That's hundreds of millions of rows, I think. It's just getting the top. So I did a limit 10 to say like basically take the head of this CSV. And so there's a lot of like optimizations in this package that are really useful for obviously you could just go in the terminal like I did before and do the head, but lots of other things you can do from within R with this package. So that's pretty useful, even on these gigantic data sets. So yeah, other than that, I think that's all I had. I only briefly look at this package, but it seems promising. Probably worth more exploration. But yeah.
Awesome. Thank you, Nick.